1 over, where are you seeing the 1 over 6? What is this number? Okay. That is when we get 0, -1. To get -1, you want to add 0 to -1. Do we get this? To get -1 as a sum, to get this -1, I added 0 to -1. Do we understand that? So the probability of getting -1 is the probability of choosing 0 and -1, or -1 and 0 if you do x, y. What is the probability of getting 0? What is the probability for getting 0 as a sum? Please, let's look. It's just like playing, but we are learning at the same time. Yes, Jacob. It should be? Should it be 2 over 10? 0. Anthony, what do you think? Do you know what we are doing to find the probability? So why don't you do it? So on this table, up, the first table is the probability distribution. It tells us the probability to get two numbers, one x, the other one y. The Z1, this table here, is the sum table. It tells us what is the sum of x and y. So to find the probability, you get the sum and you look for probability for you to get that sum. What is the probability that you will get a sum of 0? Jacob? Right? 3 over 10. Do we see that, Mason? You see why we are getting it? 3 over 10. What about 1? Pardon? 5 over 10. And then 2? 1 over 10. Get this. Okay, these little examples are better than all the theories I write. That's what I think. So now, we were supposed to do this just for us to understand theoretically. This is what we were supposed to do. I was supposed to do E of Z. It's also good to know how it is theoretically, because in many cases, you might not be able to represent the graph the way I did. Is equal to sum x, y, plus y, E of x, y, is equal to when x equals to 0, we are going to say sum when x equals to 0 of, you don't need to write this one, okay? I am just explaining what it is, of y times p of xy. I missed something to write here. I would have said 0 plus y. But should I write 0 plus y? I put y, but it is 0 plus y. then plus no, I would have said x. The way I wrote here, I started with y. That's what I'm getting this little mix up. I want to start with x. Sorry for this. So this is so if I'm starting with 0, then 0 represents y. And then I'm using x. The sum is on x plus sum of x and plus x dot xy. Then I will do the 1 of 0 with x. This will be minus 1. This is what I would have written. So now on 0, x start with negative 1. Then I will have negative 1 times p of 0, negative 1. Then x equals to 0 plus 0 times p of 0, 0. Then plus x equals to 1. I'll put here 1, p of 1, 0. I'm not used to this writing y before. Normally, you should write x first. So you will be seeing x comes before y. On my table, it's like y is coming before x, and I am mixing this thing. But I really want you to understand what I'm doing. If you don't, then I will explain again. So I will be adding like that. This is for y equals to 0. Then I will add the second one, which is for y equals to 1. For y equals to 1 will be plus x equals to negative 1. Already having. X equals to negative 1 will be, let me write it here, minus 1 p of negative 1, 1 plus 0 p of 0, 1 plus 1 p of 1. Please, do you see what I am doing? Even if I'm making the mistake, but if you understand what I'm trying to do, it will be very important. That's really what I want you to see. That we want to now separate the sum in a theoretical manner. The negative 1, what is p of negative 1, 1? Negative 1, 1 is now starting from up. Negative 1, this is negative 1, 0. So we have minus 1 over 10. Then plus 0 times 0, 0, we ignore that one. Then plus 1 times p of 1, 0. You can see p of 1, 0. 1, 0 is 2 over 10. That's 2 over 10. Minus 1 p of negative 1, 1. Negative 1, 1. What do I have here? Negative here. This should be plus, not negative. No. Okay, we are here with 1. -1. This 3. Then for x equals to, now for y equals to 1, we will have x plus 1. There is a mistake here again. Here we are starting this guy. So we will do y equals to 1 and x equals to -1. We start with x equals to -1. So what should be here? 0. And here we are doing 1, 0, 1. So we are adding. So this should be 1. And here we are doing 1, 1. This should be 2. So we take each number, we add them, and the probability to get them. That's essentially what. So this will be 0. And then this will be 1 times P of 0, 1. P of 0, 1 is 3 over 5. And P of 1, 1 is 1 over 10 times 2 plus 2 over 10. So what I want you to observe is that to use this method is a little bit more confusing than just do this one that I did here. To define the addition as a probability distribution. And if we want to find a mean of z, it will be -1 times 1 over 10, 0 times 3 over 10, 1 times 5 over 10, 2 times 1 over 10, which will give us what we have here. Yes. This 3 over, oh, sorry, 3 over 10. So which is equal to 6 over 10. So simply put, I could ask you to find the mean of x plus y. This is what you will do. Let's do x times y. Before we do x times y, I want us to do e of x here. E of x will be -1 times 3 over 10. E of x, look, x is -1, 0, 1. And the probability of x are 3 over 10, 4 over 10, 3 over 10. Do we see that? So E of x will be -3 over 10 plus 0 plus 3 over 10. And what will be E of y? E of y will be 6 over 10. So I want us to observe here that E of x plus y is equal to E of x plus E of y. Now let's find we want to find P of X times Y. Is equal to sum on X, sum of Y, X times Y, P of XY. I'm not going to do this one again. I did it just for you to know what the meaning of that what is the meaning of this. But we can say again, let W equal to X times Y. And let's make a table for W. If multiplication, we have 0, 0, 0, negative 1, 0, 1. So the values of W are negative 1, 0, 1. The P of W, W is a product. What is P of negative 1? What is P of negative 1? When the product is negative 1, what is the probability that we have a product of negative 1? What is the probability that the product will be negative 1? What are the numbers that when you multiply, you get negative 1, and how do you get it? That's the equation. What is the probability that the product of the two values is negative 1? 2 over 10. What is the probability that the product will be 0? So do we all see where he's getting it from? And then the product will be 1. E of W is negative 2 over 10 plus 1 over 10, which is equals to negative 1 over 10. And this is not E of X times E of Y. So what we want to learn do you see what I'm saying? For addition, we have the sum. For multiplication, we don't have. The sum, the product is not the product of the expectation. I want to change the screen here. So we define independent random variables are random variables whose joint distribution is the product of their marginal distribution. That is, P of XY is P of X times P of Y. That's a special type of distributions. When two distributions are independent, did we write that last time? Yeah. When two distributions are independent, their joint distribution is the product of their marginal distributions. And we did this example. This is an example like when you toss a coin and X was the first toast, number of head. Y, first toast, second toast, number of head. Naturally, by the nature of that experiment, the random variables are independent, which we can see from this distribution. So they are independent because each number that you see at the cross here is row, probability of row and probability of column. That's how we see it on a table. This is the theorem we want to learn today, that the mean of the sum of two distributions is the sum of their mean. If the random variables are independent, the product, the expectation of their product is the product of the expectation. I just gave you an example here where you saw that the expectation of the product was not the product of the expectation. So this can happen if the variables are independent. Are we getting this? This can happen if the variables are independent. Product can carry over if the variables are independent. Have you all done discrete maths? Anthony, you did discrete math, right? Mason? So do you remember when we say if and only if? So we are saying that if X and Y are independent, then the expectation of their product is the product of their expectations. But we are not saying that if the product of their expectation is the expectation of the product, then they are independent. I want us to get this. So we want to prove these two results and then give some examples. So the first thing to prove is E of X plus E of Y. This is in general. Whatever the distribution you have, you should be able to have this. The proof is E of X plus Y is equal to the sum over X, the sum over Y of X plus Y plus P of X. This is by definition. If X and Y are two discrete distributions, this is the way we will define the expectation of the sum using that formula for G of XY. So because of the distribution law for multiplication, we can put parentheses here, meaning that if you have to do the sum, you can do all the sum for Y before you multiply them by X. So this will be equal to sum over X of, let me even keep it and write it this way, X, P of X, Y, plus Y, X. This is again the distribution property. Let me put this parenthesis now like a big bracket here. And this, we can write it as sum over X, let's be careful about this, sum over Y, X of X, Y, plus sum over Y, Y times P of X, Y. This is equal to sum over x. This x can get, the sum is over y. The sum is over y, so x is a constant, it can get out. But here we cannot do that. This is sum over x. This guy, if you remember how we define the marginal distribution, is P of x. P of x is when you fix x and you add all the y. So we will write it as x, Px of x. For this one, sum of y, y. So this is sum over x of x times P of x plus sum over x of the sum over y of y, P of x. Then this first one is E of x. The first term is E of x. For the second term, we are going to replace the sum. It's writing sum of x before sum of y. You can replace this position of the sum with the condition that that sum exists. So we were supposed to assume that the sum exists. But if the sum does not exist, what we are doing is meaningless. So we are assuming that this sum exists. So when you get to calculus 4, we will give the condition that, like integral. Some of you have done integral, multiple integral. You do x before y or y before x irrespectively. You are able to do that because the problem is made in a way that that sum is convergent. If it is not convergent, it goes to infinity somehow, and that kind of manipulation doesn't work anymore. So, but you are always having it convergent. That's why you feel free to do that. So we will assume that it is convergent, and I will do the sum for x because before the sum for y here by P of x. And this is equal to E of x. You can begin to see where we are going to get to. Now the sum inside is over x, so y is a constant. This is E of x, and you can see that this is plus E of y, P of y. That is this part of it. This part is P of y. Py of y is the marginal distribution of y because the sum runs over x for a fixed y. You run over x for a fixed y, so it becomes P of y. So that is why this equals to E of x plus E of y. Just work out your brain to understand how those things are going. That's the main purpose of learning proofs. Okay. Let's do for E of x times y now. In all of this, we are assuming convergence of our sums. You know, if you're adding 1 to 1 to 1 to 1 indefinitely, you get infinity. So when you are doing things, you should make sure that you are to infinity, which we call a series. We will assume convergence. That both are convergent, and the sum is also convergent. And we have that. But because we are always dealing with a finite cases are always convergent. So now, if x and y independent, show that E of x times y is E of x So we will do the same thing. E of x times y is sum over x, sum over y of x times y, E of x y. Because x and y are independent, this can be written as x times y, just like P of x times P of y. I could put x and y under the P, but let's just know that whenever we see x is P x of x, then when cy is Py of y. So which is equal to the sum over x. If I take this one as a sum over y, if I take this as a sum over y, then everything in x can get out. So I can take out x P of x times sum over y of y P of y. And this is equal to sum over x of x P of x times E of y. Because E of y is a constant of x, we can take it out. We have E of y times the sum x P of x, which is E of x. So this equals to E of x. So next time I'm going to give you an example that shows that you can have two random variables that are dependent and still satisfy this property. Because what we are saying is that when they are independent, they satisfy this property. I gave you an example where they are dependent and they don't satisfy this property. I will give you an example when they are dependent and they satisfy this property.